Now it's time to introduce Taylor Meadows, founder and CEO of Change Captain. Taylor will take us through the importance of software change management in preventing costly outages. He'll start with a big picture view of AI's capabilities before diving into why it's crucial not to rely on software blindly. Through real world examples, Taylor will illustrate how well designed change management processes reduce risk and prevent unexpected disruptions. Please join me in welcoming Taylor.
Hi, thank you for joining me today. In this presentation, we're going to do a dive into software change management and AI compliance and why we should trust or question the output that we are receiving. By the way of introduction, hi, I'm Taylor Meadows. I'm a prior Big Four auditor and CPA turned software founder. At Change Captain, what we do is we automate compliance for software development. So essentially help eliminate the need for auditors to audit your software while providing management with visibility into what's actually happening in your software development pipeline. So how much time did it actually take a developer to write that one line of code? How much time did it take QA to test that one line of code? That way, organizations can improve their operational efficiency. And then we use that data to automatically generate their software capital expenditure report in order to obtain research and development tax credits, as well as meet a new regulatory requirement from the IRS called Section 174, starting in Q1 of next year. Getting into the presentation, we're going to do a quick high-level overview of what is AI and why we should be questioning the outputs. Then we're going to be looking at some real-world case studies. And then we're going to look at how is software change management tested today? What are the auditors looking for? How are they testing your organization? And then what are some mitigation strategies that you can take in order to reduce these risks? And then I'll leave a little time at the end for some Q&A. So getting into AI. So what is AI? Why do you care about it? And why is everyone scared of it? A lot of people today are think that AI is going to replace their jobs. It's going to create this Terminator scenario where they're suddenly computers are going to become our overlords. That is definitely not the case, and that's not what AI is today. Today, what we are calling AI is really a large language learning model, or an LLM. However, what's really interesting is that there is a technology that could potentially create that future, which is called a quantum computer. And what's really interesting about quantum computers is they operate on something called qubits. And qubits are different than how our current computers operate using binary. So think of binary like the zeros and ones that you're used to seeing. But qubits operate on any value between a 0 and a 1. So think how many values that is. It's infinite. And that's what makes these computers so much more powerful than what we have today. A quantum computer is 100 trillion times more powerful than today's supercomputer. And it's because it's able to perform simultaneous calculations rather than performing sequential calculations like our computers do today. And this power would allow them to completely destroy all our modern day encryption and cryptography. So that's why governments are spending billions every year in order to be the first to figure out how to control these computers. Because that's the thing, these computers aren't in a sci-fi movie. This isn't fake. These computers have actually been around for 26 years. The very first quantum computer was built 26 years ago by IBM in partnership with Los Alamos Laboratories. But the problem is while we have the hardware, we don't have the software to control it. So we essentially have a Lamborghini, but we're a toddler. Our legs are too short to reach the pedals, and our arms are too short to reach the wheels. We have this amazing machine, but we can't control it. And that's why there's such a big race to figure out how to actually control these computers, just because of the massive potential that could be used if we had access to this type of power. Looking at the different types of artificial intelligence, there are two main types: narrow AI and general AI. One is not necessarily better than the other. They each serve their purpose and have their own value. So narrow AI is focused on allowing computers to do very specific tasks, and they are able to run much cheaper, much quicker. They're more cost effective. While general AI is what you're probably more used to working with, that's your chat GPT, where it knows a lot of knowledge. It's able to answer a lot of questions. But that's where narrow AI has the advantage in the fact that it's not distracted by all this erroneous data that it doesn't need to know to perform its one specific task. So again, narrow AI or general AI, one isn't better than the other. They both serve their purpose. As I was talking to you earlier, what we are calling AI is not true artificial intelligence. Computers are not thinking like you and I do. They're not able to think for themselves. What we are calling AI today is called a large language learning model. And it's basically using predictive recognition, where it's doing a lot of pattern recognition in order to figure out how to answer your question. So it's looking at all the data that it was trained on, whether it was scouring the internet or it was uploaded data. That is what it's learning from. So if there's mistakes in that data, it's not able to differentiate. So that makes it more risky, where we need to make sure that we're questioning what it is providing to us. Plus, there's also a issue where AI tends to hallucinate for some odd reason. We haven't really been able to figure out what's causing this or how to stop the hallucinations. Um, but again, the AI, while it's extremely powerful, it's not perfect, and we just have to make sure that we are then questioning those outputs. Getting into the other type, before what we are really talk about is LLMs, machine learning was heavily leveraged in order to perform a lot of algorithms and statistical analysis, especially in the business world. That was very common practice. Now LLMs are starting to replace a little bit of this machine learning today. Today, there are tons of different AI tools on the market. Many of these you probably already recognize. OpenAI, that's your chat GPT that probably many people have been using. Really powerful. That is a general AI that's able to answer a lot of different questions and generate a lot of different images. Then we have Microsoft Copilot. Microsoft Copilot is basically Microsoft's version of ChatGPT. But what's really cool about it and what's different is it directly integrates within your Microsoft applications that you use today. So your Microsoft Word, your PowerPoint, your Excel, your Outlook. So it allows you to get that AI right there with you and almost be that peer reviewer, helping you generate content, helping you improve what you're working on. It's a very powerful tool. It's not as good as what I would like it to be, but I think it has massive potential. Gemini is Google's version of ChatGPT, very, very similar, general AI. Then Sora is the newest one on this list and really, really interesting. This is from OpenAI. And what Sora allows you to do is use text based prompts in order to generate videos. So right now, I think it caps it at about a minute, 15 seconds for how long the video can be. But it's amazing how just by entering some text, it can generate that video. And you can go in there and be very specific. Oh, hey, I want to change the cat's tail from red to blue. And it can actually make those types of changes. Really, really interesting. And now people are talking about when's the very first movie that we're going to watch that is completely generated by artificial intelligence, where there are no actors, there's no one involved. It's just using AI to generate a full feature length video. Jasper is an AI that's heavily used in the marketing and SEO space to help manage a lot of blogs. IBM Watson is kind of the engine that powers a lot of different chatbots. Think of your like a lot of different robocalls or the chatbots for like a help perspective. A lot of that is being powered by IBM Watson. And then my personal favorite is called GitHub Copilot. And what GitHub Copilot does, it allows developers to write a lot better code and write it a lot faster. Now, a lot of people think that Copilot is going to start replacing developers. That is definitely not the case. It is just another tool. It helps them move a little bit faster. Think about if you're asked to write an essay. It's a lot easier to write an essay if you already have some bullet points to work off of. That's kind of the same idea where GitHub Copilot is able to act as like a peer review, reviewing your code as you're writing it, able to help make recommendations of how to improve it, how to make it more concise, how to make it operate better. But there's also some drawbacks because what it's doing is it's not just looking at the code that you're creating right now. It learns based upon your entire code repository, which sounds really great because now it knows everything like what you're trying to do, what you've already created. But the problem is that if you already have security vulnerabilities or bad code in other areas of your code repository, and to back up, a code repository is essentially like a code warehouse, similar to how a company may have a physical warehouse to store their physical assets. This is where a code repository is where a company stores their digital code. But the issue is that the AI isn't learning bad practices. It's taking those security vulnerabilities and it's propagating them all throughout your repository. So now it's not just one vulnerability in one location, it's getting populated everywhere. So that's the concern with AI. Very powerful tool. I would say it probably helps maybe get you 20% of the way there, but you still very much need a developer today. This is not replacing developers anytime soon, but powerful, powerful tool to really expedite development. And then I wanted to talk about while all this is amazing and really powerful, we still need to make sure that we are questioning the outputs. Because where do these AI models get their data? And how do we trust the code that goes into these AI models? How do we trust how models learn when it's humans that are the ones providing the data? Garbage in, garbage out. So here is a simple little math problem. Not something that I personally would be able to do today, maybe back when I was in high school, but I want to just give you a quick demonstration of what chat gpt is capable of. So let me flip screens here. Okay, so I'll go ahead and paste in that math problem that you just saw. And what's really cool about this is not only is it able to solve the problem, it's able to walk and show its work. So never has it been easier to learn something new. If you want to try to learn something, you don't need to go to Google anymore and read through 20 different websites to figure out the answer to your question. Now you can ask a very pointed question and get a very pointed answer. It's so much easier now for students to learn something new. It's easier for all of us to learn something new. These tools are really, really amazing of what they can do. But like we were talking about earlier, we have to question the outputs that we're getting and cannot just put our blinders on. So now we'll just do a simpler problem. What's 2 plus 8? We all know that 2 plus 8 is 10. So why did it show me 11? The reason is because behind the scenes, I injected some logic that told the AI to treat every single time it sees the number two like the number three. So again, this just goes to show it's important that while how amazing these tools are, we have to make sure that we're questioning the outputs that we're receiving. So let me jump us back into the presentation. Okay, perfect. So today, there are a lot of restrictions placed on AI. Many of these are good, even though one of the things that I noticed is that a few months back, you were unable to use ChatGPT to generate images of trash. Why? I have no idea. They've since fixed this, but it was just a very kind of interesting situation where it wasn't able to generate images of trash. It said that it doesn't have basically the authority to generate these images. But similarly, if you try to use your ChatGPT to figure out, hey, how do I make methamphetamine? How do I, do these bad things that we don't want people using AI for? It stops you. It does not answer those questions. It does not help you with any of that, which is awesome, which is really, really great. That's what we want. The problem is that pretty much every single one of these AI models that we've been talking through, and you can find very, very, very similar AIs on the dark web. On the dark web, all of these restrictions have been removed. So it's not just you and I that get the benefit from this artificial intelligence in order to expedite our work and learn much faster. It's also the bad actors. They're able to create a lot better attacks. They're able to learn faster. They're able to use this technology against us. That's where we have to make sure that we're that much more due diligent in our practices, especially around security. So, jumping into some of the case studies, we're going to talk through three different case studies today. The first one is CrowdStrike. I'm sure many of y'all here recognize this outage. It was a $5.4 billion outage that grounded a lot of planes and took a lot of systems offline. Essentially, if you got the Microsoft update, you were unable to boot your computer. Then we'll talk about the Change Healthcare breach that resulted in a $2.3 billion to date. And then lastly, we'll talk about SolarWinds, which is the largest cybersecurity breach to date at $100 billion in losses. And this one's different because this wasn't basically a bad actor trying to go after money. What they were doing is they were doing a supply chain attack where they weren't just breaching SolarWinds, they were using SolarWinds as a bouncing board to then infect and go after all of their customers. For those that don't know who CrowdStrike is one of the leaders in cybersecurity. They're trusted by over 21,000 organizations. And one of the things that's really interesting that CrowdStrike is one of the few cybersecurity platforms that doesn't just help prevent known vulnerabilities, but it's looking at key metrics and information about your machine in order to help detect anomalies in order to prevent what's known as zero-day attacks. So essentially, this is where this attack has never been seen before. It's never been documented, but it's looking for those anomalies to be like, hey, this shouldn't be happening. Why is this happening? I'm going to, kill this process or quarantine it because this is really suspicious behavior. So it helps to mitigate those zero-day attacks that it's the very first time anyone's ever seen this type of attack. So amazing, amazing, amazing technology. What happened during the outage is that a single developer basically developed some code and was able to deploy it to production without any testing, any oversight, or any approvals. It was July 19th. It was a Friday afternoon with the idea that, hey, if something breaks, I'll fix it when I'm back in the office on Monday. What's the worst that can happen? Well, we all know now. So what ended up happening is this impacted almost all Windows machines, where if they received the update, it caused a blue screen of death. And what that is this update wasn't there's well, let me back up. A computer is basically there's two main components. You have the kernel level and you have the user level. The kernel level, think of it as almost like your cement foundation of your house. And then you have the user level, which is your wooden frame, everything that goes on top. Well, this update was going into that kernel level, into that cement foundation. So it was a very, very core element of the software. The problem is that if anything ever goes wrong at the kernel level, it's designed to crash. So, and it's not just crashing the CrowdStrike application, it crashes your entire computer. And that is done by design because all the alternatives can be significantly worse, or it can lead to a lot of data corruption or even actual damage to your machine. So that is by design. And that makes it that much more risky because if this same crash happened at the user level, this would only make the CrowdStrike application fail, not your entire system. But because your entire system was failing, you weren't even able to boot your computer. You weren't able to then receive the new update to then fix this issue. So what happened is now every organization had to get physical access to every machine in order to boot into what's called safe mode. It's kind of like a limited version of your operating system that you're logging into, like a limited version of Windows. And that allows them to access the that file within, it's called regedit, but that's where they were able to find that update, delete it, and then restart the computer. And then the computer would successfully boot, get the new update from CrowdStrike, and everything would be good. And all this was because it was one configuration file that a developer hard coded to look for 21 inputs. The problem is there was only 20. So when it started looking for the 21st input, it couldn't find it. So it didn't know what to do. So as a result, we got our blue screen of death and we got our crash. So it just goes to show how important it is to make sure that we have strong controls around our software change management and how reliant we are on technology today. In addition, it was a great example of why we need to make sure that we have clear disaster recovery plans where everyone knows what to do in case a situation happens. Going back to the airlines, Delta struggled quite heavily in order to basically rebound when all their computer systems went down. While if you look at like American, for example, they were able to switch back over to pen and paper in order to get their planes back in the air and still operate. And this is not to point blame at Delta or anything like that. They're an amazing company. It just to show the importance of making sure we're doing these fire drills, making sure we're not waiting until it's too late to figure out what do we do in this situation. And then it also shows the impact of our vendor tooling in that, for example, American did nothing wrong. But because CrowdStrike had a failure in their code, now all of a sudden American is down. They have an outage because of one of their vendors they're using. And this also shows the importance of why we need to make sure that all code is properly tested, approved with enforced separation of responsibilities before that code can be deployed, which would have helped actually catch this issue. If they would have did any testing around this, they would have seen that the machine literally wouldn't even boot. And then where possible, make sure that we have rollback plans in place. In this situation, this was a very high risk change because it's, again, at that kernel level, there's no way to do a rollback because you can't boot into your machine. So that's why they had to get that physical access to fix this bug. Now, getting into the Change Healthcare breach, what Change Healthcare is, for those that don't recognize it, they process over 50% of US medical claims and manage over 15 billion claims totaling more than $1.5 trillion a year. And they're owned by United Healthcare. So they're a very, very large um, component of the healthcare industry. So having this go down had a massive impact on the industry and on patients trying to receive care. So what happened with this breach? It happened on February 19th when the exploit was shared by Screen Connect. So Screen Connect is kind of like a screen sharing software. Well, they found a vulnerability in their software where if a user simply navigated to the URL for their setup wizard and they added one character, just a forward slash. By adding a forward slash, it opened up a brand new window where it said, please create your username, your password, and assigned whatever permissions you would like to this account. So, as a result, that's why Screen Connect then shared this with all their customers, saying, hey, this is a level 10 vulnerability. Here's a patch. Go patch your systems. The problem, it wasn't just their customers that was receiving this message. It was also the bad actors that received this message and they just started scouring the web trying to find an organization that hadn't patched this exploit yet. And then they were able to use that exploit in order to get into the Change Healthcare system, in order to implant ransomware around their database, as well as getting into that code repository we were talking about earlier, in order to bring down their operations and basically ransom the organization for money. And again, all this was caused by a single character, one little forward slash. That was the problem. The Change Healthcare breach impacted millions of delayed prescriptions and prevented prescriptions from being unable to be processed. And this really impacted a lot of these smaller mom and pop type doctor's offices where they have to pay their employees. So the problem is they can't get anything approved by the insurance. So they can't get the money that they need to then pay their employees' salaries. And as a result, United Healthcare announced a $2 billion emergency fund in order to help bridge this gap, which was very much needed in order to make sure that these organizations can pay their own staff. In addition, they ended up paying a $22 million ransom in order to get their data back. The interesting thing about this is that when they paid that ransom, they paid the ransom. Here's the 22 million, but they paid it to essentially a middleman. Once that middleman received the money, they said, "Hey, thanks, appreciate it. I'm just gonna pocket that right here, and I'll be on my way." So all of a sudden, Change Healthcare is like, "Well, where's my data?" And the hackers are like, "Pay us our 22 million, and we'll send you the data." What do you mean? I already paid you the 22 million. So it's not clear whether or not Change Healthcare ended up paying the ransom twice, but that just goes to show that even if you are paying the ransom, there's no guarantee you're going to get your data back. And there is absolutely no guarantee whether or not did they just make a copy of your data, which is most likely to happen. Where, yeah, you may get your data back, but now they still have that data and they're going to go use it for malicious means or other ways to make more and more money off of it. So it just goes to show it's where at all possible we want to try to prevent these breaches rather than trying to take the ransomware approach. This Change Healthcare breach was so instrumental and impactful that this was the very first time in history that the FBI, CISA, and the Health and Human Services had created a joint task force in order to help mitigate the impact of this outage. So, looking at some of the outcomes, it shows the importance where we want to make sure that we're continuously updating our vendor software and that we are having clear security, implementing those security patches in a timely manner, as well as where possible, we want to make sure that we have good segregation of duties. So, not one person holds keys to the kingdom, as well as have good change management controls and logical access controls to help secure our environments. Getting into the SolarWinds breach, what happened with SolarWinds is it was a piece of software called Orion. And the bad actors were able to breach this Orion software through something called a code compiler. And think of a code compiler almost like an oven, where I take all these ingredients, I put it into a pan, and I stick it in the oven. It bakes, and I pull it out, and now I have a souffle. That's similar to what a code compiler is. And it was during this baking process is where the bad actors were able to inject their malicious code into the Orion software. So now this software has all this malicious code. It's then signed by SolarWinds saying, hey, this is trustworthy. This is from us. Please take this update. And it was sent to their customers. But what's interesting is that now anyone who took that update is actually ended up getting breached. So just like what we were explaining earlier, how we want to make sure that we're continuously updating our software in order to prevent security vulnerabilities, this was the exact opposite, where if you took that update, that's what enabled you to get breached. For those organizations who didn't have their Orion physical boxes connected to the internet and were unable to get those updates, those customers didn't get breached. But for over 18,000 other customers, they got breached because of this supply chain attack, where they were able to go after SolarWinds and use it in order to attack all of their customers. And the attack was really, really sophisticated in the fact that so they used basically the way they got in was called Sunburst. And Sunburst is essentially the front door of how they got into these 18,000 customers. But once they got in, they didn't want that Sunburst to be discovered. So what they did is the very first thing they did once they got in was created a back door called Teardrop. And that's where they used that back door in order to then copy all the customers' data and pull it back to these Russian hackers who did this. And that way, if Teardrop was ever discovered, who cares? I'll just use Sunburst to basically reinstall Teardrop and recreate my backdoor all over again. So yeah, you got rid of my backdoor, but I still got my front door. So really, really sophisticated attack here. And this breach was focused more around getting data rather than trying to make money. And how this attack happened is it started in September 4th when attackers first accessed SolarWinds, but it wasn't until May 20th when follow-up attacks on the victims began. So, we're looking at almost a year later when the attack started, and then they were able to continuously go in and capture all this data, and we weren't detecting it or figured out what was going on until December. That was 7 months later before we figured out what was going on. So the outcome of the SolarWinds breach, again, was the largest cybersecurity breach known to date. And this is where Biden put in place an executive order called 14028, which created SBOMs. Think software bill of materials. Just like many of the items in your pantry, where if you look at the back, you see all the different ingredients that went into making that particular product. Same thing with software. This is where you want to have that clear visibility to where is your code coming from? Is it coming from a trusted source? Do they use best practices? This is where we're creating that clear chain and visibility into what's happening. So getting into how do we audit software change management? Again, we trust but verify. Is it a shark in a seal costume, or is it a seal in a shark costume? Today, auditors typically test a sample of 25 changes out of a population of typically over 200,000. So that means we're only testing 0.01% of all software code changes. And that's not because they're being lazy. It takes a lot of work to test all of these code changes. These 25 code changes can take a team of 7, 8 people over a month to test just 25. So it's not feasible for them to test over 200,000 changes. But that's where we want to understand, and how are we getting comfort that is your code any good, and is there anyone in there that's pushing malicious code like what was happening with SolarWinds? When testing software change management, it's broken up into three separate categories. The first one is going to be your code environment. So this is where we're basically looking at your configuration settings. Want to make sure that your code repository, again, that code warehouse, is set up correctly. It has the correct configurations where it doesn't allow inappropriate actions to occur. But we can't just look at a point in time. We have to look over the entire year in which we're auditing to make sure your company is following best practices for that entire year. So we're having to look at all those logs. Same idea is that we have to look at also your users' access within the system to ensure, one, no one person has kind of keys to the kingdom where possible, as well as making sure that no one has any inappropriate access or potentially has multiple accounts to your code repository where it looks like you could have segregation of duties. But the reality is that Bob has Bob account 1 and Bob account 2, and the Bob 1 account was the one who developed the code, and Bob 2 account approved it. The system says, oh, hey, there's segregation of duties here, but there's not. It's just that Bob has 2 accounts and was able to bypass these controls. Getting into actually looking at the software code changes, again, today we're typically only testing 25 software code changes out of over 200,000 on average. This is where a lead developer, we want to make sure that a lead developer is reviewing all the code before it gets merged, as well as was there any vulnerability scans that was performed on this code, and what were the outcomes of those scans. Then we'll look to see whether or not there was any pull request reviews slash QA approvals. And what a pull request is this is just kind of a technical term where a developer is essentially raising their hand saying, hey, I want to make a code change. I want to add code, edit code, delete code. That's all pull request really is at the end of the day is, hey, I want to make a change. And then we want to make sure that there's proper testing and approvals, again, before that code gets deployed. And then we want to make sure that we're doing that throughout the entire year. Last piece, this is on the CapEx side of the house. This is more on the finance side. This is where companies are able to get research and development tax credits. And that is extremely beneficial for organizations where they can often get around like a 17 to 20% tax break using their obtaining software research and development tax credits. But this is where it's important for us to go in and make sure that where are they getting the data in order to determine what is considered capitalizable versus non-capitalizable software development. How do I know that's reliable? And are they using that data consistently to obtain your research and development tax credits? Is that consistent with what you're reporting to the IRS under Section 174? And is that consistent with what you're using on your 10K on your financial statements, where you're able to essentially spread out the cost of software development, where software is not like a piece of fruit where it expires in 3 to 5 days. It has some sort of long-term value. So we want to recognize that expense in combination with the time period in which it created that value. So that way we can spread out the cost of software development over 5 to 7 years, significantly increasing a company's profitability. And that's where the Change Captain solution really comes in order to automate, honestly, everything we just walked through. And this is what Change Captain does, is it directly integrates and connects to your GitHub code repository, again, that code warehouse, where it puts in place preventative controls to ensure that all code has to be properly tested, approved with enforced separation of responsibilities before the code can be deployed. And because of that enforced separation of responsibilities, it adds a layer of security for the code repository such that no one person can have keys to the kingdom. So no one person can develop code, test it, and approve it. So now a bad actor has to breach at least 3 of your code repository accounts and at least 3 change captain accounts. So that's 6 accounts across 2 platforms that a bad actor now has to breach in order to inject malicious malware or malicious code into your code repository. And this also is giving management a lot of visibility into what's actually happening in their software development pipeline. Where are my developers spending their time? How much time did it take them to write that one line of code? How much time did it take QA to test that one line of code? And then, like we were talking about, automatically generate that capital expenditure report so I can obtain my research and development tax credits. And this is also giving companies a lot of legal risk mitigation in case they were to ever have an outage. Now they have hard evidence to show through due diligence I did everything reasonably possible to prevent this outage from happening. So you essentially can't, life happens. You can't sue me over that. So now getting more into the software development lifecycle, we're just going to do a quick overview of how software is built. So who today understands how code is developed, tested, and deployed? We'll walk through a quick little analogy on how is code developed today. So first you have commits. Think of these as like sentences that multiple sentences are then create a paragraph or a pull request where these are then sent up to the server and in order to then impact or make a change to the code that's sitting in the server. So after a developer creates 1 to multiple commits, that gets grouped together inside of a pull request, and that's sent up to the server in order to actually make that code change. Then once that pull request is sent up to the server, that's where it will get reviewed by the lead developer. So just similar to how an editor will review the writer's words, same idea. The lead developer reviews the code that was written to make sure everything is appropriate. There aren't any vulnerabilities or mistakes in the code before it can progress. Then when there is enough code in order to basically write that book, the editors will do one final review. They will make sure that not only is there a code review, there is a proper QA testing around these code changes to make sure that everything is working as intended. And then they will start getting the book ready for publishing and releasing that to customers. This is essentially like a new version of software for your customers. So connecting it all together, what we discussed today was what is AI, what's artificial intelligence, and the implications of the data feeding our AI models. And then we looked at some real world case studies around showing the importance of having preventative software change management and segregation of duties within our environment. And then we did just a quick little overview analogy of how is software built today. So you have a general idea of what is actually happening. And that way you get a little bit of visibility of how is code developed that we use every single day. Thank you for your time. I hope this was something interesting and informative and you learned something new. Please let me know if you have any questions. Happy to answer any questions you may have. Thank you.
Thank you, Taylor. A very thought provoking session. Now, let's jump into the question and answer session from the audience. If you have any questions, feel free to type them in the Q&A panel below. So, starting with the first question that we have, why is it important to verify the data used to train AI models? I believe, Taylor, you are on mute.
Hear me now?
Yes.
Okay, perfect. So yeah, the reason why it's important to train or look at the data that's feeding into your AI models is because at the end of the day, AI is just another form of software. It's only as good as the data that's being fed into it. It's only as good as the code that was used to create it. It's just another piece of software. And because it's humans that are the ones that are providing the data that's creating the code, therefore our is valuable because we are valuable. They're not going to be perfect, and that's why it's so important to make sure that you always question the outputs that you receive.
Okay, great. Jumping to the next question. How can automation improve the audit process and reduce compliance cost?
Yeah, so that's where it's really important to be able to leverage automated preventative controls, putting it on the front end. That way, it eliminates the need for auditors to do manual detective testing, and that can significantly expedite audit engagements and reduce audit fees. And that's what our Change Captain platform does: is it eliminates the need for auditors to perform the manual testing for their software development audits.
Okay, perfect. So moving to the next question, how can automation improve the? Okay, I believe I've already asked that question. How does enforcing segregation of duties help prevent potential security vulnerabilities?
Yeah, so that's just important to make sure that one person doesn't have keys to the kingdom. That way, if a one individual account doesn't have the ability to go in, develop code, test it, and deploy it to production, that was, ultimately what caused the CrowdStrike outage. Was that it was a single developer who developed their code and deployed it without any testing, any oversight, any approvals. We want to make sure from a true system limitation, no one person has that ability. That way, we want to always make sure there is that peer review before anything makes it out to our customers.
All right. So the next question is, what are some potential issues within AI-powered code suggestions?
So one of the potential issues with the AI code suggestions is if you look at how GitHub Copilot works, it's not just looking at what you are creating at that point in time. It reads and learns from your entire code repository, which is extremely beneficial because it has an idea not just of the small little slice of pie that you're working on, but it is able to understand the um, entirety of your project. The problem is that if there are any mistakes, if there are any security vulnerabilities throughout your code repository, is not able to differentiate or recognize, hey, I should not be using this code. So it learns from these mistakes and then it propagates these mistakes throughout your entire code repository. So now you don't just have one security vulnerability, now you're going to have 15.
All right. So the next question that we have is, why is it important to verify that? Sorry, what are the hidden financial impacts of failing an audit?
Yeah, so that's where if you look at right now, on average, an organization will see a 19% drop in their stock price over the next 12 months after they receive material weakness. So it really shows the huge financial impact that it can have on an organization to seeing a 19% drop. And that's not even considering the fact that on average, an organization should be going up at least 7% a year. So when you take that into consideration, you're really losing out on 20%, 26% in your stock price over 12 months.
That sounds good. So let's jump to the last question that we have, which is, why do most organizations struggle with auditing less than 0.01% of their code changes?
Yeah. So today is not that auditors are lazy in any sense. The reality is that manually auditing all these software code changes is very manual, very time consuming, as I just walked you through in the presentation. And so that takes a team of 7 to 15 people over a month to test 25 code changes. So it's not reasonable or feasible for a team to go out and test over 200,000 code changes. So we are constrained by our limitations of what is achievable today. And that's where Change Captain is kind of changing that story, where we're able to provide that 100% audit assurance where all code changes have to follow these best practices in order for the code to be deployed.
Okay, perfect. So these were all the questions that we had for you today. Taylor, thank you again for joining in and sharing your expertise with us. Before we end the session, do you have any closing thoughts for the audience?
I'd say the big thing is AI is a powerful tool, but make sure that you're questioning the outputs. And if you have any further follow-up questions about the Change Captain platform, happy to show you a demo.
Perfect. So thank you all for joining in. Stick around. We have more sessions coming up after this. And once again, thank you, Taylor.
Thank you. Appreciate it. Have a great day.